speaker is going to just talk to you, but we're going to video presentation. So we'll be posting the video of the presentation and the Q&A. The second thing is our topic is blockchain. How many have heard the word blockchain? Okay, a couple of you. I think it's going to be really mainstream in your career, and so that's why I'm introducing it in this course. It has many applications beyond sustainability, but certainly has some within sustainability. I sort of think of blockchain as a tool within cyberspace protection, cybersecurity. A weak analogy, just so you can get a sense of where it's going if you haven't heard the word. The common way that we protect things, money, diamonds, food, when we ship them, is to have what's called a chain of custody every time the item changes hands. From, let's say it's berries grown in Peru that some restaurant in Columbus has paid a lot of money for and wants to make sure that the berries that ship are the ones that get to the restaurant every step along the way. When it changes from one mode of transportation to another, there's a certificate or something that gets signed off on. There's a lot of ways that those chains of custody can be broken and are broken when there's enough financial incentive to do that, like if the items aren't cherries or berries, but maybe diamonds or money. And so blockchain is, one of the applications of blockchain is to protect the security of that item through this blockchain technology, which creates a digital record, and that digital record can't be broken or interfered with by anyone other than the people who are part of the transaction. Not a great explanation. I'm sure Jeff will do a better job of it, but that gives you the sense of what we're going to be talking about with sustainability applications. Jeff Trickett, our speaker for today, I met him about 20 years ago when he was doing odd jobs, remodeling houses, and I hired him and a few of his buddies to help install a steel beam in a house that I was renovating. But we somehow kept in touch, and a year or two, maybe a little more ago, I learned that he had started his own information technology consulting business, and one of his interests was blockchain. So he came in and talked to last year's version of this class and had some interesting results from that. So I asked him to come back in this year, and like we're doing this year, last year, no notes, no PowerPoints, just the video. So both the Q&A and the presentation. So Jeff, thank you for being here. He has with him Eric Lehman, sitting here with the camera in front of his face. He's more than a cameraman, however, he's working with Jeff on some of these blockchain projects that have a sustainability interface. So, Jeff, thank you for being here.
Yeah.
Take it away.
Yeah, thanks for inviting me again. So, just out of curiosity, and I'm repeating this, but I was just curious, how many people feel like that you have a decent understanding of what the blockchain is, beyond just hearing it or hearing that introduction? Anybody want to take a crack at trying to describe it or explain it? Okay, cool. So last year, so as Neil mentioned, we did this last year. Almost no one actually had heard of the blockchain at that point. So it's interesting because it seems like, you know, it's definitely growing in awareness. We're finding more and more applications for it all the time. Yeah, it is a powerful set of tools. One of the big things that I would, because I know that Neil's goal here is to help prepare you guys for, you know, you being in a sustainability role in an organization and being able to provide some insight into some of these tools and how they can be used. And one of the big things that I would say is that the blockchain is actually, it's an interconnected set of technologies that we've actually had for a while. We're actually leveraging you know, like advanced cryptography and different ways of structuring data in order to make it unforgeable. So these are the real key pieces about the blockchain family of technologies. And I will say, The blockchain itself, be aware, it is a buzzword. The key technology that brought the blockchain into the world was Bitcoin. So I'm sure everybody has heard of Bitcoin. It has helped to really revolutionize our understanding of what can be done with currencies. There have been a lot of other cryptocurrencies that have followed suit right behind it. But the blockchain was the underlying technology that supported Bitcoin, and that's how it became famous. So it's really a combination of ideas that were already, a lot of different people were trying to solve some problems with cryptocurrencies. And they added a technique that we've been using for a long time called the Merkle tree or the hash tree. And it revolutionized what had been being done, and it brought forth this whole new possibility in how we're protecting data and why this distributed ledger. And that's a key thing to keep in mind. The blockchain is a distributed ledger. That means that we're all sharing one data set amongst ourselves. There is no central place where that data lives. In most technologies that we use today, there are central servers that make that data available. You connect to it, it does some things, it updates the data, and then next time you access the database, you have the new data. But in a distributed data system, which is what the blockchain is, you're actually sharing that data across an entire network of nodes. And that's what the term is called. So everybody has records on your system or your computer or whatever regional server you're accessing. And every time there's an update, it has to distribute that information across the network.
And the network are the parties to a transaction.
Yeah.
We're not talking about the world,
It's everybody who has who is running a node of whatever the blockchain that you're talking about is. So it could be you and I are making a transaction, and in Bitcoin's version of this model, they've got this thing that is called mining. Has anybody heard of like Bitcoin mining? Anybody know anybody who was hoping to get rich doing Bitcoin mining? Yeah, so it's actually a pretty cool thing. What it means is that you can buy specialized equipment, and you can run these hashing algorithms on these. What you're essentially doing is reverse cracking passwords. You can just put it that way. So like when you are signing up for an account on, you say like your bank account, you create a username and a password, and those two things are combined. They do what is called a hash generation, which is representing that combination of characters in one very small text string. And that text string can only be mapped to that one data set. So what it does is it gives you the ability to verify that what you think you're dealing with is exactly what you are in fact dealing with. So that's another really key point here is you can think of it as like, when it's like your seal of approval. When in medieval times you receive a letter, you've got your wax stamp on it, and that's what gives you the confidence that this is actually a letter that came from so-and-so, and I know that it is because it has this wax seal on it. That's essentially what a hash is. It allows you to take a big block of data and boil it down into this one character string that uniquely represents only that one data set. And if there's a single character that's off, it'll have a totally different string associated to it.
Back to Bitcoin mining and making money. If you make X dollars, somebody loses X dollars, don't they?
No, it's a medium of exchange. So yeah, if you make X dollars because I make a transaction with you, I'm giving up those X dollars.
No, but I'm talking about which I don't fully understand, the mining by itself.
Yes.
How is it that some people have made a lot of money without a similar number of people losing that amount of money?
Yeah, so
where does the value come from?
Yes, and that's a really interesting question, because this is one of the places where people don't really understand Bitcoin very much in most cases. And what you're actually doing is, so anyone who's mining Bitcoins, they're using, and I'm trying not to get too far into the technical weeds here, so just guide me back on if it's a little too deep. But what we're essentially doing is any of these miners, if you're mining Bitcoins, what you're really doing is you're competing with all of the other miners in order to reverse crack a specific simplified hash in order to add another record to the ledger. So I'm going to say that again so that it's not, maybe I'll say it a little more clearly even. So every single transaction that you make with Bitcoin or anything else that you're dealing with in this sense, all of those transactions are getting sent to a network, and those, in this case, that network is all of the Bitcoin miners in the world that are mining Bitcoins. Those transactions are sent to these networks, and they are compiled into data structures. And everyone who is trying to, you're finding the solution to the reverse, like you're cracking a username and password. That's really what you're doing. And you know how when you create a username and you have to include X number of characters and it has to be capital, lowercase, and special characters? That is because you're increasing the complexity of your password so that it's harder to crack, right? Because you've got computers that are designed to do nothing but crack these things. And in fact, that is what Bitcoin is, that's what it's running on.
So does a successful crack then just create more Bitcoin value?
That's exactly what happens. So if you successfully crack that hash, what it does is it allows you to add another record to the ledger. And in this particular case, you're going to take all of the transactions that have happened since the last Bitcoin has been mined, bundle them up, and add it to the ledger. And because you have the unique solution to this problem, you send that solution out to the rest of the network where it's validated so that you can add that record to the data set. So it's what you're doing, you're employing extremely high-powered computers to do this reverse cracking algorithm so that you have the proof of work. That's what they call it in Bitcoin. You've got the proof of work so that you have the green light, essentially, to add that data to the network, and then it's propagated across the network.
You, in essence, have printed money.
Yes. Yeah. And in exchange for solving that problem, the miner actually receives Bitcoins. So that's actually what they're doing. When they're adding this new data to the ledger, part of that data represents a new Bitcoin that they created that is assigned uniquely to them. And the way it's done today, they distribute this. So like instead of you competing with everybody else, what happens is you get into these computing pools where everybody splits the Bitcoins when somebody solves it, and you distribute that processing power. But the proof of work piece is actually, in my opinion, it's the weakest aspect of Bitcoin. It makes it incredibly inefficient. It makes it burn through so much electricity. I mean, the amount of electricity and hardware and components that go into this is obscene, really. I mean, it just burns through equipment and burns through electricity. Now, again, Bitcoin was it was kind of like the world's introduction to this, and there have been a ton of cryptocurrencies that have followed behind it. And there are projects like Ethereum that are providing valuable resource like computing power as a service, and that you can create models that will automatically transact money based on different patterns, and you can do all kinds of pretty amazing things with this. The idea of smart contracts, which smart contracts, it's the same, well, depending on the use case. It's essentially it's validating that contract is valid, and it keeps a safe copy of it distributed across the network. And so it gives you the ability to, so say historically, you and I might enter into a contract, right? And, you know, I might keep a copy of it, you might keep a copy of it, maybe I have my attorney keep a copy of it. But, you know, it really comes down to, you know, you have to have that original copy in order to validate that this contract is valid. And what this kind of a technology does is it allows you to have absolute confidence that that specific contract was written exactly the way it is. I can't overwrite words, there's nothing I can do to forge these. They've actually been battle tested by the world, fighting over, you know, like people have really tried to crack this thing from every angle. And they have done it with a lot of the mediums of exchanges, like the clearinghouses, the different banking connections of how it ties into the rest of our financial system. But these core algorithms and the encryption technologies, this has been really good for this because it has put it through its absolute highest value test that it could have, because there's a huge financial incentive to break this. And a lot of people have been trying without any real success. So it's very good for the world of cryptocurrency. And I would say that what my biggest recommendation in looking into the world as you go out into, you know, being a part of an organization and maybe being able to bring insight to this, is keeping in mind that, again, the blockchain, it's really a buzzword, because, you know, the true blockchain itself, it was it's intrinsically connected to Bitcoin. And there are a lot of other kinds of blockchains that have been put together. There are a lot of other things, and in my opinion, I think that the future is in like blockchain-like technologies that are not specifically the blockchain. There's no guarantee the blockchain will still be around by the time you graduate, right? I mean, the technology moves very, very fast. That's just it's the nature of it. And, you know, there are newer and better enhancements that are made that are not compatible with the original blockchain. And that's what we're seeing today. I've been implementing a lot of different blockchain projects. And one of the most promising ones is it's actually called the Tangle, and it is it's a technology called IOTA. My personal opinion, I think that's the real future of this, because rather than having the proof of work, that's the part that makes it very inefficient, we have a different mechanism that is exponentially more efficient, and it makes it distributable theoretically to infinity, because you're doing validation with just two other members of these nodes instead of having mining taking place, which is sucking up tons and tons of resources, and it also is a bottleneck. So Bitcoin, it's been estimated that the absolute maximum that will be possible for it is to do 7 transactions per second. And that is never going to hold up in a world, like a truly worldwide economy of exchange. But with these other technologies, there is no threshold there, and we're using different techniques to distribute and propagate the information. So I would encourage you, if you have any interest in this kind of a thing, it is the future. I mean, make no mistake about it. This is the world we're living in, is increasingly going in this direction, where, you know, this decentralized systems, where you have different players that are a lot of the time in different countries, different economic structures, where there may or may not be trust, and that is where the blockchain is immensely powerful. And I would encourage you to think of it conceptually, rather than, you know, the blockchain or whatever variant is taking the lead by the time you're out in the workforce. Just you know, I would recommend understanding that, you know, there are different tools for different solutions, right? And the blockchain it's great, and it has done immense things for Bitcoin itself. But so in all the projects that I'm involved with, we've built
custom blockchain solutions for this specific task at hand. So would it be helpful to get into some of that, just so they can get a sense? Because what you're talking about is an immensely flexible and resilient set of technologies here. So it's actually something that's, I would hope that everybody takes note of. I did this lecture last year, as Neil mentioned, and one of the students reached out to me afterwards. We actually met up later, and he had been very interested in the emerging cannabis and hemp market, which I don't know if how much you guys are paying attention to that, but you know, we're dealing with a sea change of legislation and how the world is interacting with this family of plants. And he wanted to know, well, is that a viable use for the blockchain? And as we dug into it, it became more and more clear. I mean, it is a really good use case. You've got different parties that don't necessarily trust each other, a desire for no central authority, and you know, wanting to have integrity and you know, being able to validate data. So he and I actually founded a technology company that works with labs to validate the testing results, so that people really know what they're dealing with, whether it's cannabis for medicinal purposes, you know, which is increasingly becoming legal in more and more states, including Ohio. You know, as well as for hemp growing, which is you know, has huge industrial and sustainability implications, like enormous, unbelievable benefits. And so just putting that out there, that is, out of the 2 classes that we lectured, that I lectured to, he's the only one that reached out. He is now the co-owner of a technology company that has the potential to revolutionize the cannabis industry. So it's something worth keeping in mind, just for everything that you guys do, every situation that you come into contact with. It's so important to be proactive, and you know, like, never underestimate what you as one individual can do, because it's pretty amazing what you can do if you put your mind to it. But so just as another example, so Eric, who is with us here today, we're working together to build a blockchain solution for folding graphene. I don't know if anybody is familiar with graphene. Graphene is another revolutionary, unbelievably powerful substance that it is essentially just carbon molecules that are arranged in a geometrically pure way. So it's pure hexagonal, it's a single plane, and you can do unbelievable things with this. Has higher tensile strength than steel, it's unbelievable. It can replace plastic, you can create permeable membranes, you can have it breathe air and keep out water and do unbelievable things with this stuff. And so,
can it be made commercially or just in the lab?
yes. And this is where this project comes in. So this is something that Eric has been working on for a long time, and it's called the Game Changer Movement. And the focus is that we're creating fun puzzle type games where you're actually folding and creating new configurations for working with graphene. So the power of graphene comes into play with how it's structured. You can have specifics of how it's modeled, how it's structured. And right now, we have this similar race happening. People are finding newer and better ways for manufacturing graphene all the time, like constantly. And so, you know, every couple months you hear about a new technique that is being proven out at this university or that university. And so part of what we're doing is finding more and more efficient ways of producing graphene at a mass scale. So that's part of what goes into this game changer concept.
This is a single layer of carbon molecules.
That's right.
And how does it differ from one configuration than another?
Well, so you can make the spacing between them bigger or smaller to selectively allow only certain molecules to get through. So just in like the medicine space, or you know, like there are so many applications just for that. But you know, you can create new materials, you can create newer and better and stronger, you know, hybridization. You know, you can do all kinds of things with it, and it's such a flexible thing. You're talking about the building blocks of life as we know it, and the same kind of complexity that comes into play with how molecules arrange themselves and how we interact as creatures. You have those same exact kinds of complexities that come into play with this, because it's carbon configured in different ways.
Are companies that we would know the name of involved?
Right now, it's at a very early adoption stage, and Eric maybe you could speak to that. He knows more about this side of it than I do.
Well, interestingly, in Dayton, one of the world's largest graphene producers happens to just be doing its thing, and that used to be called Angstrom Materials, and now they're part of the global graphene group G3. So that's a local opportunity to explore more. And then Rice University is creating a new methodology that makes it less expensive to produce. And I think the other part is like the composites and the polymers that are able to be created. So I mean, there's now going to be an effort to see what happens when you add graphene to concrete, because if you do that, then you need 1/3 less concrete for building the buildings that we all get to build. And if you do the math and you talk about sustainability, then you're talking about less fossil fuels required to transport all the materials that we need to grow our nation. So there's just a lot of different.
And I would
Question in
venture.
the back, I think, on this point. Go ahead, Roland.
I'm just wondering what the raw material for graphene is. Is it
Carbon.
petroleum?
No, and this is
So where's
part
the-
of where the breakthroughs are. This is an awesome question, because one of the newer and most promising versions of this technology is called flash graphene, and we can use compost and waste. Essentially anything that has carbon in it is a candidate for manufacturing graphene from. It was originally discovered from like graphite, right? Graphite and tape, like Scotch tape and graphite. And so it just shows how much potential there is, because you've got all these different processes that people are developing. Most of them are dirty, most of them are chemically induced. A lot of them are using explosions, and I mean there's a lot there's a lot of room for it to improve. But some of these newer techniques, they open the door for this being doable by almost anyone. So
Hemp be a possibility? Hemp a possible?
very, very much so. Yeah, we're actually exploring some of that right now. Figuring out some of the overlap between these projects. And yes, I think that is part of the future. And even anything that we've burned, so like coal and anything that has been burned and has carbon residue, that could all be recaptured and formed into graphene. So keep your eye out for it. This is definitely a technology of the future.
What about CO2?
Yeah, exactly. Yeah. It's anything with carbon in it. It's just a matter of breaking it down and facilitating it to reform in this particular matrix. And so part of what we're doing with this, so we're creating a cryptocurrency called Gritcoin, and it's specifically designed for to reward people that are playing these games and doing making other contributions towards making graphene. And we're actually using the manufactured graphene as a commodity to support the cryptocurrency. So there are several different layers of this, and this is why as I'm a technologist, so the scenario that Neil described, when I was doing construction work, we were actually pioneering it was a blockchain type concept. This was back, I don't know, the turn of the century, I guess.
Yeah, about 20 years.
About 20 years ago. And yeah, at that time, I was exploring different models to facilitate collaborative work. So, we were running these different crews, and the idea was that we were moderating the work and balancing the inputs and the outputs to have measurable outcomes that we could track. and reward the crews that were doing a better job and so on. So, you know, this is an interest that I've had for a long time, and we've been working on different variants of it. But the key takeaway is that it's always best to design your technology for the task at hand. And you know, that's a lot of the problems with a lot of the blockchain solutions that I see out there are people are essentially just throwing something up onto Ethereum and, you know, saying it's a blockchain solution. You're going to see a ton of that, and you will continue to see a ton of that. But it's really important to keep in mind that, you know, every single application has specific considerations, and you always want to customize your technology to solve the problems that you're solving. Otherwise, you're going to have you know, just baggage that you have to deal with, and you're always going to have to deal with.
What's the issue in graphene that makes it look for a blockchain type solution?
Well, because we want to certify different grades of graphene. So, you know, giving people, so it's again, it comes back to this thing, you know, like people today, and it applies to almost everything you deal with. We very rarely know exactly what we're dealing with. You know, you think you're getting Starbucks coffee because you bought it from Starbucks, but you know, it's like you're trusting that they are using the exact same beans and the same recipe and everything else. But you know, the reality is you know, you have knockoffs of things all the time. You have people that you know, try to forge things and sell them off as something else. You have quality control and, you know, materials that you build things with. You have to certify things. And without having good regulations and different, you know, mechanisms for validating that, is certifying what you're dealing with, you don't know what you're dealing with. So that's what we're doing with the graphene, is we're grading it and creating different batches and certifying that it, you know, it's precisely what you're dealing with. It's actually very similar to what we're doing with the cannabis. You know, we're running tests for, you know, different, you know, all different kinds of players. You know, we've got some people that are growing hemp and they just want to prove that it doesn't have THC in it. You have people that want to, you know, they're selling it medicinally, so they want to know that, you know, if somebody's distributing it as a, you know, as a medical center, they want to know that what they have is up to grade. So that's what we're using the blockchain for in both of these cases. We're certifying different grades of it and giving people confidence in what they're
If
having.
in a couple of years you come back and you bring some graphene with you, will it be in a bottle? Will it be in a box?
Yes.
Any of the above?
Yeah, it's an amazingly flexible material. You can have small pieces of it. It could be in solution. You know, it could be a single clear sheet. It could be, I mean, it can take on so many different forms. We are just scratching the surface of this. And I think that one of the most powerful use cases of it is it's also a super capacitor. So you've got all kinds of like battery uses that can be applied